Hello,
Okay. So anyway, I
Sriram.
have started recording. Uh, yeah. So the RRM aspects, it majorly talks about the connection management and then radio admission control. Admission means within one particular cell what eNode B is handling. Whenever user is entering or leaving or modifying something, for that eNode B has to first take control about the radio admission. Accordingly, it will prepare the RRC messages, and then those RRC messages will travel around PDCP, RLC, MAC, and PHY finally to the over the air to reach to the eNode B, UV in particular DC allocated thing. So, but this will happen via the scheduling. Once the scheduling job is to allocate the resources, but RRM and RRC job is to prepare the messages depending on the cell load, depending on the number of cells, what it is actually handling, how many cells it is handling. In order we can maintain the radio resource management. Accordingly, it can configure the messages to reach at the UV side. Along with that, it will prepare the RRC messages, which RRC messages has to be sent to this particular UV. And then eNode will send it via PDCP L2, L3 layers, L2 and 5 layers, L2 and L1 layers, in fact. So this is the network view. And for today's discussion, I am not going to talk about MME, S gateway, P gateway, because of today's air interface discussion. Our within our time limit, we can focus on air interface aspects, and also my expertise is in air interface. So let's have a look at the UV and eNode B interaction. So to recall the protocol stack, both for the control plane and user plane for the LTE, we have eNode B is communicating to MME via the NAS protocol. NAS is split into two parts. One is EMM and ESM, and RRC. It is a radio protocol again. It is responsible for controlling the resources. The resources here means either the PDCP configuration, RLC configuration, MAC configuration, and PHY configuration. These are all the things we call it as a resources, but those are all controlled or in fact configured by the RRC. eNode B will send the RRC messages where the configuration is placed, and UV will receive the RRC configuration, and then accordingly it will interact with the PDCP. So it will tell to the PDCP, this is the your PDCP configuration in uplink or downlink, whatever. And then for the RLC also. So for the RLC, we are going to see few modes are there, TM, AM, and UM. All the things we have both uplink and downlink, but only for few of the things we have downlink, like UM mode, which is unacknowledgement mode. We are going to see that. Then MAC to MAC interactions and PHY interactions. So in the control plane environment, there is an involvement of NAS and RRC. Please try to note. NAS and RRC will come into the picture only in the control plane, not in the user plane. So accordingly, if we have a look at in the next picture, which is user plane. So user plane contains only PDCP, RLC, MAC, which is combinedly we say it is L2, and 5 layer we say it is L1. On top of that, what will be there at the UV side? It is IP layer and UDP layer and the application layer. Because we are in the control plane, we are dealing with like for example YouTube kind of data or WhatsApp or any payload, in fact. Uh, but in between PDCP, RLC, MAC, in between, we have the terminology that we have discussed in the first day discussion, like SDU and PDU. SDU means Service Data Unit, and PDU means Protocol Data Unit. These are all the terminology which exist across the L2 layers. Either it can be PDCP, RLC, or MAC. When it comes to 5 layer, the language is transport block. Mac can be sending PDO, but Phi understands in the language of transport block. So each transport block can be formed as one of the channel, maybe like PDSCH channel or any of the channel, PDCPH and all. Then let's understand the overall design picture, UV design overview. Uh, So first of all, what UV needs, UV wants to connect to the network, and at the same time, UV wants to send something or receive something, the data. So for which, because it is going wireless and the coverage is bounded by the operators, so we need to provide the PLMN information, means like service area and the coverage area, whether it is Vodafone or Airtel, and also what is the subscription, what is the configuration about the subscriber, So that's why we have something called as USIM, which is universal SIM, where the 4G SIM card will be present in the phone. So apart from USIM, whatever you can see, everything is a software. So SIM is inserted in the place where it is provided in the phone. But SIM has the connectivity with the NAS. We have something called as AT commands, like alert commands, through which we can trigger or we can query the 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 stack information, or in fact the entire phone information. Like for example, this particular phone, what is the IMEI number, or what is the SIM card number? It is belonging to which operator, whether it is 2G enabled, 3G enabled, or 4G enabled, and what is the current signaling strength it is capturing. Many different things. While it is connected, what are all the different, whether it is connected to default, whether the default bearer is activated or dedicated bearer is activated. So these are all the different scenarios what UV can understand through this AT commands. So the AT commands, we will get the output from the NAS. So NAS will give, because NAS is just not the only functionality which is talking to MME, but at the same time, on top of the NAS, there is AT command manager. On top of that, this USIM will be there. On top of that, our AT command interface will be there, where we can get the inputs, or we can get some queries addressed there. And coming to the RRC, RRC is the one which is playing a major role for configuring. As I said in the previous discussions, RRC is responsible for configuring the different layers, but it is not mandatory that every instruction is followed by every PDCP entity. Here you are observing only one PDCP, one RLC, one MAC, but in fact it is depending on the quality of service to be satisfied. There can be multiple entities can be present. Means entities means one instance of RLC, instance of PDCP, but MAC is only one instance. RLC and PDCP are multiple instances, because those are all closely related to IP packets and sequence number handling. But MAC and PHY are completely related to, very close to the air interface, where we can observe the transmissions and retransmissions between the UV and the eNode. And then coming to the PHY layer, DSP0, DSPN. It means like it is a mix of hardware and software, but DSP, multiple DSP cores will be present, because in the phone we won't be having the like normal computer Intel kind of processors, like normal processors. These are all high capacity processors, which are where the the digital signal processors only can fulfill all those requirements in terms of fastest processing, and also it will be in synchronous state. And in the hardware, you can see analog to digital converter and digital to analog converter. That is where we are actually finally connected to the RF port, and then accordingly it will reach to the air, and then it has its own issues in the propagation environments, in the signal processing phase, like MIMO issues and all, beamforming and all. So uh, uh, so this is the overall picture about the UV design. We can see the many other aspects, like whatever we have missed here, RLC TM and RLC UM AM in the coming discussion. But I will go forward by just concluding about this MAC in this slide, about the multiplexing of multiple channels. There is a channel which is, there can be multiple channels, which is like CCCH, DCCH, as a part of channel mapping we have seen. So those things will be multiplexed and then a PDU map PDU is formed, and uh, that PDU is sent to the physical layer, which is understood as a one transport block by the physical layer. And accordingly, in the RX phase, it will demultiplex whatever is coming from the eNode B side. Now let's have a look at the eNode B design. Uh, Here in the previous slide we have seen like what UV is doing whenever it is receiving, but in the eNode B, apart from the user plane and control plane, some messages like RRC messages, for example RRC connection request, that is sent by the eNode B. Here the RRC is maintaining something. uh, for example, these are all the things what RRC is maintaining with respect to the quality of service, with respect to the whatever the message is coming from the MME, where it can directly keep in the RRC message as a part of NAS. Imagine that RRC is one big box. So in the RRC big message, one small NAS message is kept, and that will be transferred over the air. But UV, when it will interpret is, it will reach until the NAS. Nobody will touch this NAS encapsulation message. Means either the MAC or RLC or PDCP, including RRC, because that can be understood only by the NAS. So it has to reach till the NAS. So after reaching the NAS, means RRC will internally send that NAS encapsulation information to the NAS. Then NAS can understand whether it is ESM message or EMM message or mobility management or authentication message. If you can recap uh, from the NAS attached call flow, LTE service, we have seen a big call flow. So from that, yeah, you can understand the NAS message will be understood by the user. So the other things like SRBs and DRBs, we have three SRBs in LTE, which is for handling the control signaling, and DRB for 8 DRBs for the data plane messages. In fact, user plane data will be sent across these things. And for the handling, we will be creating multiple entities. So these entities will be there both in UV side and eNode B side for all the layers. Then RRM will come into the picture. RRM, as I said earlier, it is for managing all the different RRC related configurations for individual UVs. And then in the MAC, the same thing what you have observed in the UV case, the same thing will be there. But in addition to that, we have the MAC scheduler that I am going to discuss much more in detail for today's discussion. So moving on. Okay, so this is about quality of service bearer handling in eNode B. This is the overview about the basic scheduler functionality. Means scheduler, how it actually decides about assigning the resources or sending or preparing the DCI formats. So that is based on like payload selection happening in the RLC, and then in the MAC, and then retransmission. Because of the so many other issues, retransmission issues also might come. So all these things, eNode B scheduler has to take care, and according to the channel state information, it will understand the modulation scheme and also the resource assignment. I'll try to answer at the end of the session. Kindly, please allow me to complete the presentation. So this is about the quality of service handling. So the quality of service is split into different bearers, bearer 1, bearer 2, bearer 3. And accordingly, after multiplexing, it will reach to the different HARP processes. We have eight HARP processes in both UV and eNode B in case of LTE for the FDD configuration. But for the TDD, we have 16 HARP processes. Again, it's a different topic altogether, but this is especially used for ULSCH or DLSCH processing. So because we are going via shared channels, DLSH and ULSH. So for handling this, the HARC will come into the picture. But for the HARC, the input is DCI, which is coming from the physical layer. So let's move on to the other part. Yeah. So this is the overall picture. For example, here SRB or DRB. For satisfying this SRB, different RBIDs will be splitted, and then different RLC entities will be formed. So where the input for the entity, each entity is RLC SBU. So the job of RLC entity is to convert into RLC PDU so that it can pass through one of the logical channel according to the requirement. This and all depends on whether UV in is in idle state or connected state, or it is in some handover state, depending on the UV state. And then so via the different logical channels, it will reach to the MAC for the where the scheduling decision is happening. See, you can consider this for both UV and eNode B, but the only difference is at the eNode B side, scheduler will come into the picture, whether it can be control plane or user plane. But from the RRC point of view, radio resource management, and at the same time, the RRC configurations will be prepared as the case may be, depending on whether eNode B is in the initial starting of the eNode, or in between, depending on, like, for example,
It was not
control
picking up.
plane or connected state or any other different scenarios. Now, after
I'll
understanding
send a
this
message.
part, yeah, after understanding this, you can try to understand this. Now, what if eNode B is handling multiple UVs? So the same structure, you can assume here, here, here. It means here 4 UVs are there. UV 1, 2, 3, 4. So over the air, eNode B has to send. So this is the visualization in the physical environment, in the real environment, and this is the stack environment. All these things for each individual UV. Then eNode B will send the information accordingly. It means for the 4 UVs, for example, in this particular coverage area, 4 UVs are there. Example, it means eNode B will be maintaining the different context and uh, different buffers related to RRC and RLC and sorry, not RRC, RLC and PDC and MAC also. So it means in one particular UV, the stack itself is completely independent. For example, this can be Vivo phone, and this can be Oppo phone. This can be, like, for example, Samsung phone, anything, and this can be some dongle, LTE dongle, anything for that matter. But the idea is here every protocol, the protocol stack is present in every UE, irrespective of the things. It means it is a responsibility of the phone manufacturer or the modem manufacturer to take care about how to receive the signal, how to send the signals, how to process the protocol stack. So I'm just giving the overall picture how it works in the real environment, keeping the protocol stack in mind. So accordingly, it will be sending in one of the TTI. And the down, I have mentioned the TTIs, which means it is scheduling. Now, so this is the overall picture. Now, in terms of functionality, in terms of the interactions, how my TX and RX design flow will happen. This is the overall picture in terms of control plane or user plane. Whenever there is a involvement of control plane, you can assume RRC, RRM will be there. I am talking only about L2 and L3 layers, not about. This is purely applicable for L2, L3, especially control plane and user plane. So when it comes to control plane or user plane, I am talking in a generalized view. Let's talk about first control plane. So for the control plane, uh, uh, first of all, here the blue arrow marks indicates uplink. one second, sorry. Actually, this is a typo. Blue arrow marks indicates downlink. Downlink means eNode B is sending to UV. This is downlink. This is the uplink. Uplink means UV is sending to eNode B. This is UV sending to eNode B. So here this is there is some mistake actually. Uh, this path is TX path where UV is transmitting something. Means whatever is coming from the top, like PDCP or RLC, it is sending via TX path. But while sending, according to the RBID, radio bearer ID for the quality of service, whether it can be SRB or DRB, now it is creating one entity and making sure about these functionalities, segmentation, assembly, and then RBID handling and sequence number handling. It means the moment you are talking about sequencing, sequence number means via this path, it is going to eNode B, that particular sequence number. So, and like that, it will be sending continuously via one of the channel, DTCH, for example, if it is user plane. So at the eNode B side, it will receive the sequence number. So here, what will happen is reassembly will happen, and then sequence number reordering will happen, and then all the RPADs will be collected, and then it will be sending to the top layer. So the RRC will work in this way. But here the important point what we have to observe here is earlier before sending this earlier how to behave, how the RLC has to behave should be decided by the RRC. It means the configuration is decided by the RRC, but it doesn't mean that all the information it will apply for creating the entity and activating that entity or that particular channel. That is one issue. Another one is whenever eNode be scheduling multiple UVs, there is a chances that only active users will be there as in that particular cell, and eNode B will take care only about the active users. It means eNode B will consider only active users for the scheduling. So accordingly, in the